Alright, today we're talking about the real number system. Right? The real number system includes all of the real numbers. The real numbers we're going to talk about today are rational numbers and irrational numbers. Rational numbers, it's any number that can be written as a fraction, which includes almost every number except for just a few. Numbers such as -4, can I write that as a fraction? Yes, I can write it over 1. 0.15, it's a decimal. This is a terminating decimal. I can write that as a fraction. We know how to write terminating decimals and repeating decimals as fractions. So terminating decimals and repeating fractions are rational numbers because they can be written as a fraction. The couple things that can't be written as fractions are what we call irrational numbers, and that's pi, which is roughly this number right here, but it continues on. The reason you can't write it as a fraction because it doesn't end and it doesn't repeat. It's a number that goes on and on and on and on. There's no end to it. You can always round. When we talk about pi, when we're doing circumference and volume and all that stuff with cylinders, you just use 3.14. But if you wanted to accurately represent pi, you couldn't do it as a fraction. Okay? The same thing with the square root of 5. It doesn't end, it doesn't repeat, it just goes on and on. There's no actual end to it. Right? Most square roots are like that, except for the square roots of squares, such as the square root of 4, that's 2. Right? That would be a rational number because you can write 2 as a fraction. But you can't write this as a fraction and get every one of these numbers because it goes on and on. There's no end to it. Right? So that's what the difference between rational and irrational. Right? The sets of irrational and rational numbers together make what we call real numbers, which on page 543 of your book, right, has this diagram, and it's the set of real numbers. Everything in here is a real number. There's only one thing that's not a real number, and that is what we call imaginary numbers. We don't deal with imaginary numbers in pre-algebra and algebra. Right? We deal with real numbers. Real numbers include rational numbers and irrational numbers. That's why they're split like this. You have irrational numbers here, you have rational numbers here. Irrational numbers like 1/4, 0.2 repeating, right? -7.5, those are all just examples of rational numbers. Included in rational numbers are integers. We know what integers are. Integers are negative numbers like -1, -2, -5, -10, and whole numbers 0, 1, 2, 3, and 10, and 100, and 1,000,000. The one thing you need to know about integers are integers don't have decimals and they don't have fractions. Just like whole numbers don't have decimals and they don't have fractions, right? Integers don't either. -6 is an integer, but -6.5 is not an integer. Just because it's negative doesn't make it an integer. Just like this, -7.5, that's a rational number. It's not an integer because it has a decimal. Included in rational numbers and integers is whole numbers. Numbers like 0, 1, 2, 3, 5, 10, 15, 20. These are examples of numbers that are whole numbers. Whole numbers are integers, but integers aren't always whole numbers. -3 is not a whole number, but 0 is a whole number and an integer and a rational number. Does everybody see how that works? Okay? So here's rational numbers. Irrational are things like pi, the square root of 5. A number just like this, a random number that doesn't end because it has the dots and also doesn't have a repeating pattern to it. I can't find a repeating pattern, so I can't write it as a fraction. What it's going to do is it's going to give you random numbers and it's going to say identify the groups that these numbers belong to. Like this. So write these numbers down. Now what they'll do is they'll give you a fraction like this and say identify all the sets that this number belongs to, this real number belongs to. But the issue is I could reduce this. What could I reduce 21/7 to? 3. So I want to identify all the sets that 3 belongs to. Right? The question you should always ask at the beginning is, can this be written as a fraction? Can 21/7 be written as a fraction? It is a fraction, so I'm going to call it a rational number. It belongs to rational. Now I'm going to abbreviate and just leave it as rat. You can write out rational if you want, or you can leave it as rat. We both know it's a rational number. Then I think, is 3 an integer? Does it belong to a set of integers? Yes. So I'm going to put int. And then I go on. Now if I said no, if it was an integer, could it be a whole number? No. If it's not an integer, it's not a whole number. But if it's an integer, then it might be a whole number. It doesn't have to be, but it could be. Is 3 a whole number?
Yes.
Yes. So it's a rational number, it's an integer, and it's a whole number. Negative 2.5. Can this be written as a fraction?
No.
So it's a rational number. Is this an integer? Does it have a decimal?
Yes.
So that means it can't be an integer. Integers and whole numbers don't have decimals or fractions. So is this an integer? Since it's not an integer, could it be a whole number? No. So all this is rational. Point 2 repeating. Right. Can this be written as a fraction? Yes. Repeating and terminating decimals can be written as fractions, so it's rational. Is this an integer?
No.
Does it have a decimal?
Yes.
Or a fraction? Yes. So can it be an integer? No. Integers don't have decimals and integers don't have fractions. So all it is rational. What about square root of 38? Okay, is 38 a square? Like 4 and 16 and 36? No. So is that number going to come out perfectly? No. So most likely it's irrational. So I'll put IRAT for that one. Okay? You can abbreviate. I'm fine with that. Okay? It's not going to end and it's not going to repeat. It doesn't have a pattern to it. It's just a random number. So it's irrational. Write this down. Given a problem like this, they want you to solve and they say a squared. A, when you square it, gives you the number 36. Okay? We know how to solve this because we know how to find what square roots are. We know what the square root of 36 is. So, again, the goal is always to get the variable by itself. Right now, it's a times a. I got to get just one a. To do that, I square root it. Because the square root of a squared is a. Because the square root and a square cancel each other out. Okay? This is canceled out by that square. So all I have left is a. So I put a square root sign above it. What I do to one side, I have to do the other. So I have to square root 36. What's the square root of 36?
6.
It's 6. What else is the square root of 36? I told you yesterday there's two numbers that give you 36. What is it?
Negatives.
Negative 36 or negative 6. So I put plus or minus 6. The book will write 6 or negative 6, but I'm fine with you writing it just like this. Okay? Because A, does it tell me A is a positive number? Anywhere in solve does it say A has to be positive? Does it say A has to be negative? No. So how do I know which one's which? I don't. That's why I give you both answers. Because 6 times 6 gives me 36, and negative 6 times negative 6 gives me 36. So either of them are possible answers, right? And unless it tells me something else, I have to assume both of them are the right answer. Okay? All right, write this down. So here I have 2n squared equals 170. I cannot just put a square root sign over 2n squared. Can't do it because the 2 messes it up. I can't do it. But to put a square root sign around this, I have to have it just where it's n squared, okay, or d squared or x squared. I can't have a number in there. Well, how would I get rid of the 2 if I have 2n squared? Kurt? Okay, just like we've been doing all year long, to get a number away from it, I do the opposite of what's doing. It's timesing n squared by 2, so I divide both sides by 2. So 2n squared divided by 2 just leaves me with n squared. 170 divided by 2 gives me 85. Now I have n squared by itself. How do I get n squared to be n? What do we do?
Square root.
I square root. I put a radical sign on both sides. So this is going to give me plus or minus. And I figure out what the square root of 85 is. Now the book, it assumes you get a calculator. So it says write the answer to the nearest tenth, which would be 9.2 or negative 9.2. So that would be the answer the book gives you. So if you're checking your answers, this is what it wants. Now I do want to put one thing in there. I want to say one thing. on the OCCT, it doesn't allow you to get a calculator. So there's no way you're going to get this answer. So it either wants you to estimate, so your answer would be plus or minus 9, or it wants you to leave your answer just like this. Plus or minus the square root of 85. Okay? I want you to be aware of what you might see on the OCCT, which is this. Instead of working out the square root of 85, it just leaves it like this. Okay? So if you see this, don't be afraid of it. It's the same thing as this. Okay? Any questions? Do one more. I want you guys to work this problem out. 363 equals 3d squared. I always want to get the d squared by itself. I can't square root it. I can't put a radical sign above it until it's by itself. So I have to divide both sides by 3. All right, that cancels that out, so I'm left with d squared. That's what I want. I figure out how many times is 3 going to 363? Well, these are easy numbers. It's 121. Now, what do I do from here?
You square root.
I put a square root around d squared, which if I put a square root on one side, I have to do what? I have to do the exact same thing to the other side of the equal sign. What's the square root of d squared?
11.
What's the square root of d squared?
Oh, D.
D.
Oh, geez.
What's the square root of 121? What's the other square root of 121? Negative 11, so that's why I write plus or minus, and there's my answer. Guys, can I check my answer?
Yes.
Hey, could I plug 11 into right here? What's 11 times 11?
121.
What's 121 times 3?
362.
See what I mean? See how it works? Okay, could I do negative 11 plug in here? Yeah, guess what? You get the same thing, right? All right. Here's your homework assignment for today.